we've seen quite a few customers use linear antennas in mines, and so just a term that I like to use is courses for horses. And for those who understand that, because I understand it's a British term, is that what happens in mining is a lot of people use normal linear antennas, and although the majority of the antennas that we do provide are linear antennas and they are quite good, in tunnel environments, circular polarized antennas just work so much better, and I'll explain exactly why that happens. So firstly, when you have a linear antenna, as you can see on the left-hand side over here, this antenna over here, it's an upright antenna, which means it's a linear antenna. You can see that this thing, because it's mounted vertically upright, it transmits a sine wave which is in alignment with the antenna. So you've probably seen on television antennas that when you have a Yagi installed, it's either mounted upright or horizontally. And it is so important when you install an antenna like this that when you have the one side vertically installed, then the other side, the receive side, also needs to be vertically installed. As with the television antennas, when you have a horizontally installed antenna, then the other side must also be horizontally installed. So what I'm trying to say with this specific slide is that when you transmit, especially in a mining tunnel, a signal which is linear, and it is a sine wave either vertical or horizontal, but in this case vertical, it may reflect, bounce off the walls, and on the other side received at a different polarization. And when a signal is received at a different polarization, the full amplitude of the signal isn't received on the other side. So in other words, you have deterioration of your signal. So because in mining tunnels, the signal rotates unpredictably, linear antennas are not always the best option. The same with metro tunnels, the same with automotive tunnels. So in those cases, it is so much better to use a circular polarized antenna. So obviously in tunnels, the propagation is affected by the tunnel dimensions, surfaces, but we'll get to that shortly. On the circular polarization, as you can see over here, as the signal rotates, as it is transmitted, it actually contains all the polarizations. So if something's reflected off the wall and it is received, it isn't constrained to a linear situation like this. And so it just makes or provides much more reliable links. It's also as if the propagation adapts to the environment and to the tunnel dimensions. And the tunnel often acts like a waveguide for this type of circular polarized antennas. And then also quite interesting, and I'll show that in a case study shortly, is that circular polarization tends to propagate past obstacles and obstructions. So I'll just quickly touch on that in the case studies where that has become quite evident and what the results of that is. Good. So just another slide on vertical and horizontal polarization. As you can see over here with the vertical polarization, you've all probably learned in science in high school that when you have a wave, also in a water situation, you drop two stones, you'll see that there's constructive and destructive waves. And as soon as a wave like this bounces off the top and the bottom walls of the or surfaces of the tunnel, then you'll, after the first reflection, you'll start receiving either a constructive or destructive wave. What unfortunately happens is you could have an amplification of your signal, but you could also have a deterioration in your signal. What actually happens is an effect which is called fading. So the signal fades and becomes unpredictable. So you can either have a very strong signal or a very poor signal. And most of you have probably, especially in the older days when normal FM broadcasts and AM broadcasts on your car radio was a little bit more sparse, you've probably seen when you approach a traffic light that when you stop, all of a sudden your signal goes away. And then you just move forward maybe 1 meter, 2 meters, and you'll see suddenly your signal pops back again. And that is because of this phenomena. And this is quite common in all different types of communication. But it becomes quite prevalent in tunnels, mining tunnels, automotive tunnels, and so on. Same with horizontal polarization. We'll mention now about a study that was done about this, but the same effect happens. It bounces off the sidewalls. Circular polarization is a little bit different. Because of its circular nature, it tends to, when it bounces off the wall, it changes the polarization of the signal, and you have a mirror effect. So because you're transmitting a circle, imagine these, I don't know what you call these springs that you have that you send down the steps, but it changes the, so if the spring was, went down the first step in one way, it goes down and it changes and gets a mirror effect. And that causes the signals not to fade that much as with linear polarization. Good. Next slide is just to show you that you also have within circular polarization, you have both left and right polarization. So many circular polarized antennas are either the left or the right. So it's just something interesting to take care of when you select your antennas. But we'll get to that point also shortly. Good. You'll also see here that the way that the signal reflects off the different surfaces just becomes much more manageable. But the polarization does change every time it reflects off the floor.